So in this video, we're going to start our LangGraph series by understanding what is an agent in LangGraph. What is a LangGraph agent? Now, the LangChain team created LangChain so that you can be able to work with, or rather build AI workflows, LLM-powered applications. So LangChain is basically based on workflows. But then AI agents became medium of value to deliver value with AI or specifically LLMs. And today we are hearing of AI agents everywhere. Salesforce recently talked about placing 4,000 roles with AI agents. So people are really taking AI agents serious. And the LangChain team obviously saw this. And because of that, they created LangGraph. Now, the purpose of LangGraph was to actually move all the agent development capabilities in LangChain into a specialized framework. So LangChain actually had tools for you to develop agents. There's even a create React agent in LangChain. But then because AI agents were becoming very, very popular, the team at LangChain felt it was very, very important to actually create a framework specifically designed for designing agents. And that is why we now have LangGraph. And in today's video, we're going to be looking at what an agent really means in LangGraph. So let us head over to our whiteboard. Now, in LangGraph, an agent is basically an autonomous unit that can reason through tasks and take some actions, then come to a final result. So you have specialized agents. The agent is meant to perform one task. That is, if you're not in a multi-agent system, which LangGraph can also do. But for now, let us just look at one agent. Let's look at agents in terms of one agent. So it is a specialized autonomous unit that can take a task, reason through it, that is break it down through chain of thought prompting, and then determine whether it should take actions. And after a series of actions, if it's able to come to the eventual result, it then terminates. It terminates. But let us look deeper into how agents in LangGraph work. Now, in LangGraph, agents basically consist of three parts. We have the LLM. The LLM is basically responsible for the thought process. So the LLM is the brain of the agent. The LLM is the brain of the agent. It's the one that reasons through tasks. It takes its tasks, it breaks it down, and reasons through it through, most of the time, a thought, action, and observation sequence, which we're going to talk about later. So we have the LLM, which is the brain of the application. Then next we have tools. We have tools. So we have tools and we have the LLM. And most of the time, people believe that these are basically the two things that make up an AI agent. Like LLM plus tools equals AI agents. And I think in its most basic form, that is what AI agents are composed of. LLM plus tools. But then, we also have a third part, which is the prompt. So we have the prompt. And the task of the prompt is to give instructions to the agent. So the prompt is how you communicate with your AI agent. The prompt is how you tell it the task you want it to perform. And then it's going to use the LLM to break down the task and then reason through it through a cycle. And then within that cycle, it can determine whether it should use some tools or not. So this is the simple way an agent works in LangGraph. But let us look at how agents go through this cycle. Basically, one thing you should put in your mind is that in LangGraph, an agent is basically an LLM in a loop. An LLM in a loop. That's basically what an agent is. But let us look at what that loop looks like. Let me put this up here. So prompt, LLM, tools. Those are the three parts of an agent in LangGraph. But how does an agent operate in LangGraph? So what happens is, first, you give it a task. So you give your agent a task. It then takes the task and reasons through it. So it reasons through the task. Takes the task and it reasons through the task. So that is, it breaks it down. It takes the task and breaks it down. So let's say you tell it to send an email. Then it will tell itself, okay, first I need to know who to send the email to. So it can prompt you to get the name of the person or the email address of the person you want to send the email to. Then says, okay, now I need to construct the email. Then it constructs the email. Once it constructs the email, you can add an extra step to say you should walk through the email and check it out and see that everything is fine. It looks at that, everything looks fine. Then it then goes again, and now I need to send the email. How do I send the email? Oh, I need to call a tool to send the email. So it calls a tool, and the tool sends the email. It gets a response back, which is mostly called an observation. Then it goes on like that. So once it reasons, it then checks whether it should call a tool. So should I call a tool or not? Most of the time, it will call a tool, especially when it has to make real world impact or read files or read data from somewhere. It calls a tool. And once it calls the tool, it then gives the tool to a tool executor. Let me get some arrows in here. So from reasoning to tool, and from tool to tool executor. So the executor executes the tool. It then sends back the results of the tool. Then the results of the tool are basically called an observation. So the agent is going to look at those results and see whether it has met the completion requirements. What are the completion requirements? It has to check whether it has met the completion requirements. Now, if it has not met the completion requirement, it then takes the observation, which is the result of the tool call, takes the observation, looks through the observation, and then uses it to determine the next course of action. That is by going back to this reasoning step. So it goes back to this reasoning step and goes through the loop again. So it goes through the loop over and over, and every time it gets the observation, it would always check. It would always check if it has met the completion requirement. To always check if it has met the completion requirement. So basically what happens is that it takes a task, it reasons through it by breaking it down. It then takes step 1. It checks whether it needs to call a tool. If it needs to call a tool, it gives it to the tool executor. The tool executor is going to operate and is going to return results, which are called observation. Now, when it checks the observation, it's going to check if the observation or the results of the tool call meet the completion requirement. If it doesn't, it will go back to reasoning. And it just continues to go through those steps one by one until it is able to meet the completion requirement. So that's why I said agents in LangGraph are basically an LLM in a loop. So basically that's how agents work in LangGraph, as we've seen. Let's give this color. Now, what are some of the other components of an AI agent? Like I said, in its most basic form, in LangGraph, an AI agent simply consists of a prompt, an LLM, and tools. The LLM is the brain, the tools are the action takers, and the prompt is how you pass instruction to the agent. But what are other components that that LangGraph provides? First is memory. So we have memory, and this memory can be divided into two. We have short-term. So the current session of the AI agent is what is called the short-term memory. That the current session in which the agent is in is what is called short-term memory. And when the agent operation terminates, that memory is gone. So it's transient memory. That memory is gone once the agent operation terminates. However, if the agent needs to reference memory that needs to be stored somewhere, then it has to make use of long-term memory. Long-term memory. So it needs to make use of long-term memory. These include, let's say, semantic information about objects. Also includes data, maybe a user base, customer base, and stuff like that. These are things that you cannot just stuff all in the memory all in the short-term memory or the context window of the AI agent. So long-term memory is for any information that you need to persist, that the agent will always have to reference from time to time, while short-term memory is meant for the current operation of the agent. Think of it like your RAM and your hard drive. So your RAM is the short-term memory, while your hard drive is the long-term memory. So we have memory. That's one of the components you can also find in a LangGraph agent. And we have human in the loop human in the loop capabilities. Human in the loop capabilities. Now, human in the loop capabilities is the ability for the agent to pause operation, so that a human being, that is you or anyone using the AI agent, can actually intervene in the current action. Maybe it needs to send an email, then it asks you, is this email okay? Can I go ahead and send it? That is an example of a human in the loop operation. So you can then say, yeah, go ahead and send this email. So you can intervene for things like approval, like we just described. You can also intervene for things like correction. You can choose to like edit the email, edit some things in the email before it goes. And you can also just take over. You can also just take over and say, yeah, I will take it from this point. Thank you for drafting the email. You don't need to send it yourself. I'm going to send it myself. So for approval, for intervention, and also just to take back manual control, you can employ LangGraph's human in the loop capabilities in its AI agent. Another thing you get with LangGraph agent is streaming support. Now, while an agent is in operation, it will be very beneficial for you to see its activities, to in real time know what it's doing. So there are tools in LangGraph that will help you output things like tokens consumed, steps taken, the reasoning process. Like I said, there's a thought, action, observation pattern that these agents go through. Thought meaning that they look at the task and kind of break it down. Then they decide whether there's an action they need to take. If they take the action, whatever result comes from the action is called an observation. So they look at it, see if it meets the completion criteria. If it doesn't, it goes back to the thought step. So probably want to see those steps as the agent is operating. A lot of people want to see what is going on with the agent, or even log it. So you can stream those type of outputs. You can stream tool call results. You can stream model tokens and stuff like that, just to see how it's consuming tokens in between operations. So that's another thing that you get out of the box with LangGraph. Now, to wrap up this video, let us look at how you can build agents in LangGraph. Let's look at how you can build agents in LangGraph, because that's what we're here for, and that's what subsequent videos are going to be. That's what I'm going to be teaching in subsequent videos. How can you build agents in LangGraph? Now, there are two ways. You can either build agents using primitives, using LangGraph primitives, and for that, LangGraph provides the Graph API and the functional API. And you can use either of each. Whichever one fits your style, you can go ahead with that. But there is a Graph API and there's a functional API. We're also going to be treating them in upcoming videos. So the Graph API gives you things like nodes, edges, and helps you represent your agent operations in a graphical format. While the functional API is more similar to typical programming, how you typically program imperatively. So those are the two ways to use primitives. And these ways you can build your agents from scratch. You can build your agent operations from scratch. That is why LangGraph is the most customizable agent framework, because of these primitives that it comes bundled in. But if you don't want to go through all that, building things from the scratch, having to implement your own human in the loop support and checkpointers and stuff like that, you can use pre-built components. Yeah, you can use pre-built components. So LangGraph provides pre-built components that you can use to build things like React agent. I need to build React agents. So you can just use those components, and they come with a lot of these capabilities out of the box. You don't need to implement them manually. So based on the level of control you're going for, how granular it is, you can either use the primitives, which you have the Graph API and the functional API to work with, or you can use a bunch of the pre-built components that come out of the box. We're going to be playing around with the two of them. We're going to be spending a lot of time with the primitives because I want to teach you how to build everything from scratch. And we're also going to be using the pre-builts. And with your knowledge of the primitives, you can know the benefits of the pre-built, and you can also learn more or understand how you can customize them to what you want. But that's how agents work in LangGraph. But for this video, I hope you now understand how agents work in LangGraph.